let's go through LeetCode 2009 minimal numbers of operations to make array continuous. So for this question, it gives us integer array nums, and let us to return the minimal numbers of operations to make this kind of array continuous. So the operation is that you can change in one operation, you can replace any elements in the nums with any integer. So for example, 4253, we'll say this kind of array, it also defines what is continuous, is that all the elements are unique, and the difference between the maximal elements and minimal elements is this length -1. So that means if we sort, right, so I see 2, 3, 4, 5. This is continuous. And for this one, 1, 2, 3, 5, 6. And let's say 1, 2, 3. This is continuous. Here, there is 4 missing, right? So we can change 6 to 4 to make this one as continuous. So there is one operation. So intuitively for this question, we're thinking about is that we sort this number and trying to find the longest continuous subarrays. Trying to see so what we are going to do is that we are going to sort arrays, sort these numbers. And now what we are going to do is that find the longest continuous subarray. Let me see, because there is some kind of duplicates, right? So we need to dedupe first. After dedupe, then we find the longest. First is that we need to dedupe. And replace all of the rest can be at the end, right? 0 at the end. Find the longest continuous subarray. So we have a length, right? Then the minimum will be n minus length. So let's begin to write code. I think let's dedupe. So we'll have, for example, int pre equals, we know this numbers is in the range from 1, it will not be 0, right? We can set this one as 0. And the index equals -1, right? So what we're going to do is that for int I equals for every number in numbers, right? So if num doesn't equal to pre, then we'll have numbers plus index equals num, right? And we'll have pre equals num. Okay. So in this case, we move all of the numbers to be distinct in the previous from 0 to index. And we'll say for int we'll set the rest as 0, right? Or int I equals index plus 1, I smaller than I plus plus. We'll have nums I equals 0, right? So in this way, we have to do. The next thing is that we try to for each numbers, we try to start. So let's say for int I equals 0, right? I smaller than index, right? This is the last one. Actually, index plus 1, right? I plus plus. We'll have int binary search int index equals binary search nums I and nums I plus n minus 1, right? So what does this one mean is that for this every number nums I, we're trying to see this nums I to nums I plus n minus 1, how many index it covers, right? So for example, this is start from I, and we are trying to see how in the sorted part, how many index in this range, right? So that means for this kind of numbers, we don't need to do any manipulations, right? So that how many of the manipulation will be n minus index minus I minus 1, right? So because for this kind of number, we don't need to do operations. What we need to do operations is n minus this one. So let's write binary search, private into binary search nums into I. This is the start, right? And int target. So we are find the last index in nums, right? Which is smaller equal to nums I plus n minus 1, right? So so we'll see how many operations is that will have result in the result equals the integer dot max value. So result will be max dot min dot result index. We'll do this kind of operations, that is n minus index minus I minus 1, right? Because for this kind of operation, we don't need to do change. So we need a n minus this one operation. In the end, we just return this out, right? So binary search is find the last index smaller equal to nums I plus n minus 1. So we'll have int start equals I and equals we can also have an index plus 1 here, right? Because we know also have index, right? This will be the last. because we know after index plus one will be zero, right? So we can have also pass this one as a parameter. So n equals index, right? So we'll say while start plus one smaller than and we have in mid equals start plus and minus start divided by 2, right? So I say if nums mid equals to target, this is still not a last. So that means we'll have start equals mid, right? So if this smaller than target, it also start equal to mid. Else, so we can write this, right? If this one greater than end was mid, else start was mid, right? In the end, let's say if nums and smaller equal to target, then we return and otherwise we just return start. We need to have n as numbers length, right? Info n equals numbers length. This index already been defined. Let's have j, okay? J. And this will be j, right? J minus 1. J minus 5. Yeah. Um, mm, this one has two. We need to we can for everyone we sort, right? Trying to parent I, right? I and yeah, trying to see what's the problem. Mm, so the first one, math index. Math index. So 0 to 3, 0 to 3. So n minus so 0, 1, 2, 3. This is a plus one, okay. So the time complexity will be O n log n. There is sort, and also n times n orders of binary search. So it is time complexity will be n log n.